on the sideboard, you guys will have a quiz over 3.1 day 1 and day 2 next Tuesday. All right, there is a ton to remember. All the different ways that something can be symmetric. We touched origin, and now we're going to talk about the other 4 cases today. What's the matter? It's next Tuesday, yes. Okay. So, if we want to have it with respect to the x-axis, if something is symmetric to the x-axis, then this would be something that would be, if I fold it along the x-axis, the top will fold directly onto the bottom. That means it's symmetric. Okay? So, for one x value, I get a positive y value and a negative y value. And that's what I'm saying. So if x is equal to a, then y is equal to plus and minus a. So the way you test it is you plug in a, b into your function, and you plug in a negative b into your function. And you get the same looking function. Okay? It'll look the same. So if I give you x equals negative y squared minus 4, x is your a. So I'm going to substitute in AB. I'm going to get A equals negative B squared minus 4. So A equals negative B squared minus 4 without the parentheses. Right? That's when I substitute in AB. Remember, I'm going to substitute in AB, and then I'm going to substitute in A negative B. And those answers should be the same. Okay? Because for any x, I'm going to get 2 y's, a positive and a negative. All right, if I plug in a negative b, now I'm going to say a is equal to negative of negative b squared minus 4. Now look at how I'm substituting it in, and look at where I'm putting that I'm using parentheses. Parentheses are so important. Okay? I'm going to get negative b squared minus 4, aren't I? So this, when I used a negative b, is the same as this when I used ab. You powers before. Got to remember your order of operation. Please excuse my dear Aunt Sally tells me I do my powers or my parentheses and my exponents first, and then I worry about what I'm doing with my signs. Okay? All right. With the y-axis, if something is symmetrical around the y-axis, it looks like this. I can fold it on the y. And what always occurs is I get the same y value no matter if x is positive or if x is negative. So AB and negative AB are what I use for my test. That's your test. So if we use AB, I'm going to get B is equal to A squared minus 3. Right? And if I use negative AB, I'm going to get B is equal to parentheses negative A squared minus 3, which is still A squared minus 3. This case is the same as this case. Symmetrical around the y-axis. Now let me tell you, you are not going to be limited to just one of these cases. You can have expressions that are going to be symmetrical around all of these cases, or just 2 of these cases, or none of the cases. So we're testing all of these at the same time. Okay? All right. If we want to see if it's symmetrical around the line y equals x, then we know, for example, if x is 3, y is 3, right? And we flip it. We let the b and the a flip-flop. Okay? So something that might be symmetrical around the line y equals x is a circle. This is your line y equals x. Remember how we talked about last year doing inverse functions? Remember how we switched the x and the y? And that we drew that y equals x axis and we could see that one function was a reflection of the other over that line? The process for finding an inverse function is to switch the x and the y and solve for the y value again. That's how you get your inverse function, okay? So the line y equals x is what you have to fold it on. So if we use a, b, we're going to get a squared plus b squared equals 4. Right? My other case then is going to be ba. Now we're going to let x be b and y be a. We're flip-flopping those values. So now we're going to say b squared plus a squared equals, are they the same? The order is different, right? But isn't b squared plus a squared the same thing as a squared plus b squared? Both terms are positive, right? All right. So these are what we're comparing. And that's why, because they're the same, it's symmetrical around the line y equals x. All right, something that's symmetrical around y equals negative x. Well, that's this line. Still could be a circle. We'll just do a circle. Besides a circle, here, something that looks like this. So a rational function is symmetrical around the line y equals negative x. Okay? And so in this case, I'm going to flip them, but I'm going to make both of them negative. So I'm going to say, actually, So a, b, and negative b, a, they're going to be the same. All right. So if I use a, b, I'm going to get a, b equals 6. And if I use the coordinate negative b, negative a, I'm going to get negative b, negative a equals 6. So ba equals 6. Is ba the same thing as ab? Okay. So when you're multiplying, look at the sign and look at your order. How are we doing? Okay. All right. So let's try some problems. I want to know if x squared plus y equals 3 is symmetrical around all of these possibilities. So we're going to do all of our cases. I know we're going to start by saying plugging in AB, because this is what we're comparing them all to, aren't we? AB, and then it's A negative B or negative AB. These are all what we're comparing it to. So when I plug in AB, that's going to give me that A squared plus B equals 3. So this is what I'm comparing it to each time. Now, for it to be symmetric around the x-axis, what else do I have to compare it to? Okay, A and negative B. So when we plug that in, we're going to have A squared plus negative B equals 3, which is A squared minus B equals 3. Does that work? No, because I'm supposed to be getting A squared plus B equals 3, right? So that's a no. All right, what am I going to use if I want to do the y-axis? Negative AB. All right, so that's negative A squared plus B equals 3. That's A squared plus B equals 3. Is that what we're supposed to get? So we know that this is symmetrical around the y-axis. What about the line y equals x? What am I going to have to input? The BA. Right, you don't need to do it 5 times. Okay. All right, so for BA, I'm going to get B squared, right? What? Plus A equals 3, which is B squared plus A equals 3. Is that what I'm supposed to get? I need A squared, right? Plus B equals 3, so that's a no. And the line y equals negative x, what am I inputting? Yep. And so I'm going to get negative B squared plus negative A equals 3. B squared minus A equals 3, right? Does that work? No. So the only thing that this one is symmetrical to is what? Y-axis. So do you know what this looks like? This is, if only one term is squared, this is a quadratic along, but it's not x squared. In this case, it's y squared. So this is a parabola that's going around the x-axis. I'm sorry, that's not right. This is a parabola pointing down. I'm sorry? This is just, no, this is what this looks like. It's a parabola. It's actually been shifted up 3 units for the vertex, but this is a parabola. If I were to solve this, it would be y is equal to negative x squared plus 3, isn't it? Isn't that a parabola pointing down? It doesn't make sense that it would be symmetrical around anything but the y-axis. So if you need to be able to see it, yeah. This is the no B method. This is where the y-intercept and the vertex are the same value. And this one is where your y-intercept is at 0, 3, so that your parabola starts at 3 and opens down. Okay, next one. Okay, so we're going to try and do it for all. We're going to just plug in AB, because this is what we're comparing it to. And when I plug in AB, I'm going to get AB equals negative 2. Are we good? So what do I use if I want to do it according to the x-axis? What am I plugging in? Right, this is the stuff that you need to know. That's what you're memorizing. You need to be able to bring that up. It's actually on ACTs and SATs. All right, A negative B. That's going to yield A negative B negative 2. Negative AB equals negative 2, or AB is equal to 2, right? Does that work? All right, what's my next one? What axis? All right, so if we do the y-axis, we're going to do what? Negative A, positive B. All right, so that's going to be negative A, B, negative 2. Negative AB equals negative 2. Again, what do I get? AB equals 2. Does that work? Nope. Didn't work first time. Not going to work the second. Okay, what's my next one that I have to try? Okay, the line y equals x. If I try the line y equals x, then I'm doing BA. So I'm going to do B times A equals negative 2. So BA equals negative 2. Does that work? Sure, because isn't BA equals negative 2 the same thing as AB equals negative 2? All right, the last one is the line y equals negative x. And what am I going to imply here? Or input? Negative B, negative A. All right, So that's going to be negative b for my x value, negative a for my y equals negative 2. BA equals negative 2, sure, works again. So when you're doing your homework, if you're having to constantly look back and see what am I supposed to use, you need to be done with looking at it by about halfway through the lesson so that you know these rules.
When you say what is that, should we also try origin too?
Not today, but on your quiz, it'll be the origin, y equals x equals, or y equals negative x-axis, y-axis. You'll be all of them. Okay, so we're going to finish this so this is an even graph. What does an even function graph look like? Where are the tails? They're either both up or they're both down. Well, in this case, I'm showing you that this tail is pointing down, so what am I going to do? If I want to reflect it, where am I going to put this in this quadrant so that it's an even graph? Am I going to do a reflection along the y-axis or the x-axis? The y-axis, right? I want it to look like another hump on the other side. Wouldn't you agree? So this point is what? 3, 5. So if I'm reflecting it over here, according to my rules, what should this point become? Yeah, this is going to be negative 3, 5. And that's all I'm asking, so that it does this. I don't know. Or just redraw it. Because I'm wanting it to look like an even graph. So I'm going to reflect it across the y-axis. I'm going to reflect this so that I've got a hump and they're both going down. If I want it to be an odd graph, then what I want it to really do is be down here, right? So this point has a value of 3, 5. And so if I'm going to put it down in the third quadrant, I'm really going to be at negative 3, negative 5, so that it's doing that. So this point is negative 3, negative 5.
Wait, what do you mean when you say odd graph?
Remember, even functions do this. They're tails. We talked about yesterday, parent functions, if they're even or odd, positive or negative. All the way to the very beginning. Odd function, degree of 1, it's odd. Tails are either in 1 and 3 or 2 and 4. Even function, parabola, tails are either both up or both down. Okay? Is that it? Oh, no, I want neither. Well, if you want it to be neither, you can make it into a circle. Sure. So then if I'm going to make it into a circle, I'm going to reflect it over what axis? X-axis. So this is going to stay 3 and become negative 5. Okay? Any questions on this? All right.
So you've got your